Hello guys, welcome back to Maison African Motives, still on engineering science entry. In this platform, we shall be focusing on the question paper of April 2020, that is on motion, energy, and power. So we are given the first question that is 1.1 to define acceleration. So as we know, guys, acceleration is simply referring to the rate of change of velocity. Remember that acceleration is equivalent to the change of velocity over the change in time. So that simply means that our acceleration is or can be defined as, right, so let's just write it here. So you can just define acceleration as the rate of change of velocity. So is the rate of change of velocity. So this is what you're going to have in this case. So acceleration being measured in meters per square second. So you can even write that measured in meters per square second. All right. So that is the first part. Then on 1.2, we're given a diagram in this case, which is on foot one, which represents the motion of a train. Okay, so this is our train that we're given. And this train, as you can see from our velocity diagram, that is, we are given here the velocity in meters per second and the time in seconds. So that is from 0 to 50 and from 0 to 30 in terms of velocity. Determine each of the following 1.21 acceleration of the train during the first 20 seconds. All right. So remember, when we talked about this, we said acceleration is equivalent to the rate of change of what? Velocity, which is the change in velocity over the change in what? In time. So you can actually apply your formula because we can see that here the velocity change from 0 to 20, that is the time, our velocity was 15. Then it changed at 20, the velocity corresponds with 30 in this case. So which means we shall have 30 minus 15. Okay, let me just write the formula. From this change in velocity, we can write our formula as V2 minus V1 over T2 minus T1. Okay, that is the change in velocity. So meaning to say our V2, that is 30, it is going to be 30 minus 15 over T2. We started at 0, now it's 20. So 20 is our T2, so that's 20 minus 0. Okay, so we're going to simplify this, you're going to obtain something like 0.75 meters per square second. All right, so that is our acceleration. Or we could have taken the information based on formulas. Remember the formulas of linear motion, where we can say that from the first point here, we are given our time, which is at 0, up to 10, which means the difference that is the total time it was taken, which is equal to 10, from 0 to 10. Okay? So meaning to say, we can say our time is 30 seconds, right? Then our initial velocity, which is u, is equivalent to 15 meters per second. Our final velocity, which is v, is equivalent to 30 meters per second. And we want to calculate acceleration during this period of time, which is 20 seconds. All right. So from our formulas of linear motion, we understand that v is equivalent to u plus at. That means we can make a subject here transpose u to the other side is going to be v, which u is equal to at. So to find a, we're going to divide by t both sides. So by dividing by t, a is the subject, means a is equivalent to v minus u over t. So you can substitute the values that were given. Our v, that is 30, minus u, our u in this case is 15, everything over the time that was taken, which is the time of 10 seconds. So this is going to give us our acceleration, which is the same as one that we got of 0.75 meters per square second. Okay, so there are so many ways that we could have calculated the acceleration. All right, so that's what we had. Let's check that a part of the question. This time we are given to calculate the total distance of the train. Okay, total distance of the train covered after 50 seconds. So we are referring all back to the total distance. So as you can see, remember that the total distance is equivalent area at the graph. So you can utilize that to say from this point here, got a trapezium, here we've got a rectangle, or we can simply use the whole of this shape that we have in this case. Okay, so how you want to have your shape as. So in this case, the A, we are referring from 0 to 20, which is a trapezium. So you're saying our distance is 1.22. So distance is equivalent to the area under the graph. That is area under the graph. So meaning to say our area, we've got A, which is a trapezium, and the area of the trapezium, that is the half sum of parallel sides. So in this case, we're saying this side, they are parallel. So this is our A, our B, times the perpendicular height. This side, this is at 90 degrees. So this is your perpendicular height. Okay, plus the rectangle. So in this case, this is from here to here, 30 from here, so it means this is a square. Also, again, this is side squared or just side to side. Okay, so that is what we're going to have. So let's separate our trapezium. So it is half sum of the parallel side, which is A plus B. So from this point to this point, that is 15. So we're going to have 15 plus from this point to this point is corresponds with 30 times the perpendicular height from 0 to 20, which is a 20 in this case. All right, so this is for the trapezium plus for the square of this part from 20 to 50. It's going to be 50 minus 20, which is 30. Then from this point to this point, the 30, so you're going to multiply 30 times 30. So that's 30 times 30 like this. Okay, so you find your area, combine everything. This first part here, you're going to obtain 450 plus 30 times 30, which is 900. So if you add together, that is going to be 1,350 meters. Okay, so that is the total distance from this part. Okay, so if you maybe you don't understand this easier concept, you could have even divided this shape in this manner. You can have a triangle. This so this is going to be a triangle here, but a rectangle. So now you've got three shapes. You've got a triangle, you've got this rectangle, and this shape that we have this case. Okay, so that means if you are to calculate the area, you're supposed to obtain the same answer just like the previous. Remember, so distance is equal to, so our distance is going to be the area of a triangle, which is half base times perpendicular height, all right, plus this rectangle, which is length times width or length times breadth. Okay, then the last part, which is a square, which is going to be side and side, and you can just treat it as a rectangle, still it's fine. Okay, so that means we are going to have half of the base from this point to this point here. That is, it corresponds from this point to this point. That is a 20. So it's half of 20 times the height from this point up to this point, the perpendicular height, 30 minus 15, 30 minus 15, which is 15, all right? Plus the rectangle, we've got length times width, of which our length from this point is 20, that's 15. So 20 times 15 plus the last part in this case, which is this square that we talked about previously, which is 30 times 30. Remember, from 20 to 50, that is 30 times the whole of this line, which is 30. So that will be 30 times 30. So this is going to be 30 times 30. Okay, so you combine everything. We are going to obtain the same answer, which is 1,350 meters. Okay, so there are so many ways for you can even apply the formulas for linear motion, but you have to be very, very careful in applying those formulas. Okay, so that part is going to take us a lot of time. Okay, let's check the other part of the question. On 1.3, we are now given that there is a force of 250 newtons. All right, so this force is being exerted on a 20 centimeter long spanner. So you can just list our information here. So it's got a force of 250 newton exerted on a 200 centimeter spanner. So given the distance of the spanner, which is 20 centimeters. If you convert meters, remember in a meter, 100 centimeters. So you divide by 100, which is going to be 0.2 meters. Okay. Then we're given that to turn a nut through 120 degrees, Okay, so given the angle theta in degrees, that is 120 degrees. Okay, so let's check the first part of the question 1.31. Calculate each of the following. Okay, 1.31 angle in radians. So you need to calculate this angle of 120 degrees in radians. All right, so there are so many ways that we can convert our angle to radians. Okay, we can use this concept, or let me just calculate here. Remember, we are given our angle in degrees. Okay, so our theta was 120 degrees. So we can use this formula, theta in radians. So our theta in radians is equivalent to theta in degrees over 57.3. Okay, so that's our theta in degrees of 120 divided by 57.3. So this can directly give us our theta in radians, which is going to give us something like 2.094 radians. Okay, so that's our theta in radians. Or we can apply this concept to say for a pi radian is equivalent to 180 degrees. So we are converting pi in rad 2 degrees. So if pi is equivalent to 180, what about 120 degrees? 120 degrees is equivalent to how many radians? We do not know. So this is going to be 120 over 180 times pi. So we're going to have 120 degrees over 180 times pi. Okay, so we're going to simplify this change to a decimal. This is going to be 2.094. Okay, so that's another conversion that you could have taken in this case. Okay, let's check the other part of the question. 1.32. Calculate each of the following. 1.32 that equals the cost and also the distance of our circuit from there. Remember that Turkey is equivalent. So all these guys is all about the formulas, all right? So this is 1.32. So remember that Turkey is the product of cost and the distance. So we are given this case the cost of 250, the distance which is 0.2. All right, so that's 120, that's 250 times 0.2. All right, so again, multiply 250 times 0.2. So take note, this is in Newton, this is in meters. So if you multiply 250 times 0.2, you're going to obtain 50 Newton meters. So you just multiply into Newton to the meters. All right, so that was question 1.32. And question 1.33, calculate the work done. So we need the work done. So remember, we have our theta here in this case. So the work done is the product of the circuit and the theta in radians. All right, so circuit in this case. So the work done, not circuit, now it's work done. So our work done is the product of circuit and theta in radians. So this is in radians. So meaning to say, we are going to use a total, if you determined here of 50, multiply to the theta in radians, which we got 2.094. So if you multiply, our work done is going to be something like 104.7 joules. Okay, remember work done is measured in joules. So that is how we apply these formulas. Okay, so that was it, guys, of this question, having a total of 5 marks, everything. All right, 1.4, we are now given that there is a flat belt. A flat belt sits around a pulley with a diameter of 38 centimeters. Let's just take our information and given the diameter of the pulley of 38 centimeters. So if you convert to meters, that's going to be divided by 100, which is 0.28 meters, right? 100. Then we move on to the rate speed. The rate is the speed of 18.7 meters. So the speed of the belt, 18.7 meters per second, and translated to it translates 5 Newton per millimeter belt width. So the belt, that is the tension of the belt there is 5 Newton per millimeter. Okay, so I say our tension in this case, 5 Newton per millimeter belt width. Right, so we've got a lot here. All right, so that is belt width. Okay, then the other part, the effective strain, the effective strain in belt is 420 Newton. That is the effective strain. So if we have, that is effective tension. So we are given TE, which is 420 Newton, and belt width. Take note, the belt width is the one that is going to affect our thing, because we said millimeter per millimeter belt width. So meaning to say our width in this case is 21 centimeters. But for us to have our T1, this is supposed to be in millimeters. So we're going to convert this to millimeters, multiply by 10. Remember, 1 centimeter is equal to 10 millimeters. So we're going to multiply by 10, which is 210 millimeters. All right. So that is what you're going to have. Right? Read it. 1.41. How present each of the following affect the power transmitted is well in kilowatt. So you need the power that is being transmitted, and you know that power is the product of the equivalent, so which is the total of the effective tension. So that is our power, the effective tension times the velocity. We have this, the velocity, we have in meters per second, tension is the total, so it means if I will just apply this direct, okay? So sorry for that. So that means our P is going to be effective tension. We have our effective tension here, 420 times the velocity, which is 18.7. So we're going to multiply to 18.7. So it's got our power in this case. So which means if we multiply, we are going to obtain something like 7,854 watts. But take note of the instruction that we're given here. We are asked to calculate this in kilowatts. So we're going to convert our answer to kilowatts in this case. So to convert to kilowatts, you can divide by 1,000, or you can multiply by 10 to the exponent of negative. So remember, guys, it's the opposite. Kilowatt, that's 10 to the exponent of 3. So to convert to the, you multiply by the inverse of 10 to the exponent of 3, which is 10 to the exponent of minus 3. So this will be 7, 7,854. So 1. So let's say let's multiply to x negative 3. Inverse of answer that you are supposed to write in. So that is how you calculate in kilowatt. Then the other part we are given now or to calculate that's 1.42. That is the tight side force in the belt. So remember that the tight side force in the belt is our T1, that is our tight side. So the person is literally asking us to calculate the value for T1. But remember, here we refer our T1 as 5 Newton per millimeter belt width. That means we are supposed to calculate our T1 from this ratio to say, for each millimeter, we have got 5 Newton, and we have got 220 millimeters. So to obtain the total is going to be 5 times 210. Take note, guys, it's 5 Newton per each millimeter. And we have got 220 millimeters in terms of the width. So you multiply the two, that is going to be the total of the tension, which is 1,050 newtons. All right, so that is what we had in this case. Then the other part of the question, 1.43, the pulley speed in revs per second. So which means we have to calculate the value of n. So that is n in revs per second. So that's 1.43. So what is the value of n in revs per second? Remember, here we are given velocity. So we can play around with our velocity in this case, because we know that velocity is equivalent to pi dn. All right, whereby this n is per second. So to get our n, we can just divide everything that is pi and d. We divide by pi d both sides, this is 600, and our n is going to be v over d. So it's just in replacing our information, we've got our velocity, we've got our d. So we're going to substitute velocity 18.7. That's our velocity, which is 18.7. So our L is going to be 18.7 over pi times the diameter, which is 0.38. All right, so remember our diameter is 0.38. All right, so that's it. So which means we are obtaining N in revs second. All right, so that means here you divide properly, we are going to obtain something 15,664. Yeah, 664 in reps per second. So that is our N, which is the rotational speed or the rotational frequency for the given one, for the given information that we have. So it is very, very important that you list your information down. After listing the information, find the proper formula to use. The running that your formula, our formula sheet is for this formula. So try to apply your formulas properly. That is how you can actually calculate anything pertaining this part of motion, energy, and power. So it's all about your formula. List your formulas down, and then you apply the exact formula depending on the information that you're given. So that's what we have, guys, for Basel African Motives, working on engineering science and brain. Till we meet again.